Day 7, gases. My teacher gave to me 7 gases burning. And I happen to have here some thermite.
In this demonstration, I want to show you how hydrogen gas is extremely combustible. What I have here is a flask with hydrochloric acid, and I have a small wad of aluminum foil that I'm going to add to the flask. At first, nothing happens because the glaze around the aluminum foil has to be corroded. The second step in this reaction is to cover the mouth of the flask with a balloon to catch the gas that's going to be released. So I'm going to stretch this balloon over the mouth of the flask so the neck is right in the middle. And this is a very exothermic reaction as the hydrochloric acid breaks down the aluminum foil and decomposes it into aluminum chloride and, of course, pure hydrogen gas. And that's going to inflate the balloon as soon as it starts to decompose. Now, this is a really important reaction because in 1937, we had the Hindenburg disaster. The Hindenburg disaster was a giant blimp that looks like the Goodyear blimps that are filled with helium, but the Hindenburg was filled with hydrogen gas. And in 1937, an electrostatic spark ignited all of that hydrogen gas, resulting in the death of 36 passengers. And we want to find out if hydrogen gas is still flammable today. And I can feel the exothermic energy coming off the flask. It's very hot, and I can see the balloon is starting to inflate. One essential question in this reaction is, where does the aluminum foil go? Because it's going to vanish. Pretty soon, there'll be no aluminum foil left in the flask, just aluminum chloride and, of course, pure hydrogen gas that we know from the Hindenburg disaster is highly combustible. Still inflating. I can still see bubbles coming off the surface. The last step is to twist off the balloon and to test the combustibility of pure hydrogen gas. And that moment is upon us now. If you look closely, I can't see any more aluminum foil in the flask. So if you turn out the lights, this reaction will be really amazing. You might want to cover your ears. It's going to be kind of noisy as we recreate the Hindenburg disaster from a flask. Okay. In 3, 2, 1. Amazing. Hydrogen gas. So very combustible.
So this is one of my favorite demos. It's called the ooh-ah flame test. I better hear some oohs and ahs out of you. So I have 5 different elements or 5 different compounds. They're actually some metals. One of them you might know, which is salt. And we also have copper chloride, and we have some lithium chloride. Now each of these, when they burn, should give off a distinct color, the flame test that scientists use. Let's see 5 different gases. Check it out. Here we have potassium chloride. Here we have copper chloride, green. Here we have lithium chloride. There we go. Red. And then we have our strontium chloride, and finally regular salt. 5 different beautiful flames, all coming from one of the properties of matter. Ooh, ah.
Another flammable gas that we'd like to show you is the combination of boric acid and methanol. And whenever you combine an acid with an alcohol, you get an esterification reaction, or an ester. And an ester is used to make perfume or cosmetics. And so I'm going to combust this mixture of boric acid and methanol, and you'll see that we get this beautiful green flame. But look what happens when I rotate the flame in this basket. I get this amazing green fire tornado. One essential question is, What causes the tornado or the fire to rise? Well, if you look, the basket has openings all along the side, and of course fire needs oxygen in order to burn. And as that oxygen enters the sides of the basket, it combusts in the direction that I turn the basket. And so this fire tornado is turning in the direction that the basket moves as air is combusted in that same direction. Check it out, my green fire tornado.
7 gases burning, but not all gases burn. In fact, a very important gas, helium, let's see here.
Helium doesn't burn, but it does something kind of cool.